Good morning, everybody. I think we'll get started. John Holland, Chief Development Officer of Pinchin, calling in from Richmond, BC. I'd like to welcome everybody to our webinar this morning, PSAB 3280, Asset Retirement Obligations for Public Entities. This is the second in this series. The early one was presented back in April, as you see the date on this slide. In April 2022, all public sector organizations are required to report their retirement obligations for tangible assets. Anything required, constructed or developed will be required to be inventoried as part of that accounting process. And that may require a different level of study to evaluate those obligations to meet a certain level of accounting rigor. Buildings, contaminated sites, solid waste landfills are engineered to operate and fulfill their purpose, but evaluating ultimate disposal has not been part of that push up to now. So some examples of those obligations which fall under scope of PSAB 3280 include buildings with hazardous materials, with end lease provisions, fuel storage tanks, radiologically contaminated medical equipment, wastewater or sewage treatment, holding tanks, septic beds, and a variety of contaminated sites. So clearly a fairly broad variety of issues come into that category. So this is part of our practice innovation series that Pinchin have been presenting for the last 18 months, bringing up new issues that we're discovering and sharing those lessons with our client and community, client fraternity and community. So with that, I'd like to go to the next slide, please, Kaylee, which is just our Zoom instructions. Basically, get comfortable, maybe raise your hands to make sure we can be heard. The Zoom tools that we use are chat if you're having technical issues, Q&A if you have a question of the presenters, and we'll have a Q&A at the end if we have time. And there won't be any polling today. So thank you for that. And the next slide. We have three presenters today. The first presenter, apart from myself, is Marcus Sconsi, who is a partner with BDO Canada, national accounting firm based in Oakville, Ontario. Marcus has over 20 years of experience in public accounting, which includes audit and assurance services for profit and the not-for-profit sector. He is BDO Canada's educational subsector industry leader, and a large part of his client portfolio is within that sector. He frequently presents to public sector clients and industry groups on various topics and industry issues. He is an external advisor to Ontario's college sector on the implementation of PS 3280, asset retirement obligations. So thank you, Marcus. Next presenter will be Tad Berger. Tad has been with Pinchin since 2011. He has an MSc in Environmental Management from the University of Houston Clear Lake and a BSc in Agricultural Sciences from UBC in Vancouver. Tad's a member of the Canadian Contaminated Sites Approved Professional Society in BC, so he's a Ministry of Environment, a roster of approved professionals. He's also a professional agrologist. He has 24 years of environmental consulting experience, including remediating approximately 4,000 projects on behalf of Pinchin and other employers, mostly in the contaminated sites sphere. Following Tad will be Sean Douglas. Sean is the national practice leader for Pinchin in hazardous materials. He's worked in this field for over 33 years. He has a diploma of technology from British Columbia Institute of Technology, and he's an applied science technologist in the field of building technology. He's worked on over 6,000 assessment and remediation projects in the public and private sector. And the last presenter, last and by no means least, is Tim McBride, who is a BSc, a PGO in Ontario, and a QP ESA. He's a graduate of the University of Waterloo in Ontario, Bachelor of Science, Applied Earth Sciences, and a professional geoscientist in Ontario. He has 20 years experience of both environmental site assessments and landfill, working in installations, geotechnical and environmental drilling, groundwater modeling, and hydrogeological evaluations, landfill siting, soil and groundwater assessments, and subwatershed studies. So we have 4 excellent speakers that are going to talk to different aspects of this subject. I encourage you all to, of course, listen, ask questions, and make this as beneficial to all of you as I'm sure it will be to us. So with that, I'd like to pass the session over to Marcus. Thank you.
Thank you, John. So I'm going to walk you through some of the technical aspects from an accounting perspective of implementing this new standard in the coming years. Just Trying to get control of my slides here. Kaylee, if you can please send me control of the slides. Thank you. Doesn't seem to want to advance. There we go. Okay. Sorry about the technical difficulties. So some of the high-level technical aspects of PS 3280, when is it effective? So it's effective for year ends beginning on or after April 1st, 2022, which means it'll be your 2023 year ends. And what is an ARO? An ARO is a legal obligation, and I'm going to come back to that term, hence why it's underlined, associated with the retirement of a tangible capital asset. So what is a legal obligation? That's a very important part of the definition of an ARO. A legal obligation can exist through a contract or agreement, through government legislation, such as environmental standards, or through promissory estoppel. If you do have an ARO, how do you account for it? You increase the amount of the tangible capital asset and you record a liability. So you would estimate the amount required to remediate the issue at the retirement stage of the asset. You would increase both the TCA and record a liability. If the TCA is no longer in use, you would expense it as a period cost. And you would generally use a present value technique to determine your ARO. What you're going to be doing is estimating when the retirement activities will happen, and you're going to be bringing that back to the current reporting date using your discount rate. A couple of relevant standards with respect to 3280. First, 3260, which is your liability for contaminated sites. There's a difference here, a key difference. This is still in play even post 2022. Liability for contaminated sites deals with issues where you've already exceeded an environmental standard. So I'll use asbestos as an example, as I believe that's a common ARO that we're going to be seeing across the public sector. Right now, if you have asbestos buried within your walls and floors and ceilings, as long as you have not exposed it to the environment through a renovation or demolition, you do not have to record anything in accordance with PS 3260. 3280, the ARO standard, it will scope that in, however. That standard has the basis that it doesn't matter if it's exposed in the current day or not. At some point in time, you will have to clean up that asbestos when you retire the asset. Therefore, you need to make those estimations and record them in your financial statements at each reporting period. Finally, PS 3270, solid waste landfill closure and post-closure liability. That standard has been withdrawn, and those are now accounted for in accordance with 3280 asset retirement obligations. So if you already record something in accordance with 3270, you may be early adopting 3280 in order to show your liabilities there. Some of the audit implications. The scoping stage of this exercise is by far the most important, as well as the most time-consuming stage of this. It's important to build the right team. Me coming from an auditor perspective, typically it's the finance people in concert with the auditor that deals with implementing a new standard. This is not a standard that the finance team can implement on their own. You need to consult with various people across your organization, especially your facilities and your legal teams. You also need to create expectations for the type of ARO you may have, as you will be reaching out to people who aren't familiar with the standard and having to educate them on the standard as they help you scope what's in. Consultants are going to be absolutely critical. Going back to my asbestos example, you're going to need environmental consultants to help you not only estimate the amount of asbestos that you may have in a building, but also, more importantly, the cost to remediate that when you retire the asset. There's all sorts of other examples, some of which the pension team will go through today, that you'll see are absolute necessities to have consultants or experts help you measure those costs. And then finally, consulting with your auditor. Anytime you're implementing a new complicated standard, it's important to be in step with your auditor throughout the process, just to make sure ultimately that they're going to be comfortable with the process you went through when they have to sign your auditor's report. Where can you get started? If you have yet to start your scoping stage, your fixed asset listing is a great first resource that can help you determine based on the types of assets you have, where you might have an ARO. If you have capital or strategic plans in place, those can also be great tools, especially with respect to estimating the retirement dates of assets with ARO. And then finally, leases. We're going to talk a lot about environmental standards, as that's going to be your most common type of ARO, but you could have ARO associated with a lease, such as a land lease that you may have to return to its original state at the conclusion of the lease, which could entail tearing down buildings and pretty significant cost and time. So you want to make sure you're looking at those leases to identify any ARO. And then two other factors to consider: materiality. Going back to my comment about consulting with your auditor, materiality is always important to keep in mind when you're implementing a new standard, so that you don't get caught up in assessing ARO for clearly immaterial assets. And then finally, transitional provisions and discount rates for consolidated entities. It could even go beyond that. If you are an organization that is consolidated into a ministry or into a federal or provincial government, you may get direction from them in terms of consistency with some of these items, in terms of assistance with templates to help you adopt the standard, or transitional provisions or other items that a ministry may want to ensure is consistent across their consolidated constituents. So please keep those in mind as you go through your scoping process. And now I'm going to pass it back to the pension team. I believe Tad is going to go through some real life examples of ARO and start with soil and groundwater contamination.
Thank you very much. And I believe that I should be able to. Says that I have control, I don't. Oh, there we go. Just a delayed control shift. That's the issue. Okay, how are you? Hopefully everyone's doing well. My name is Tad Berger. I'm going to talk about contamination and that's effect on 3280. So first, you have to understand what is contamination. And contamination is the presence of chemicals such as metals, pollutants, hydrocarbons in the soil, groundwater, surface water, sediments. Okay, and there are a number of guidelines, either federal or provincial guidelines, that set standards for which the chemicals can be present at safe amounts. And these standards are scientific and they're health-based. So they're based on exposure levels in which risk to receptors may exist. Either those be human receptors or environmental receptors such as fish and wildlife or plants. So how does soil and groundwater become contaminated? It comes contaminated from the usage of a land, and in many cases, the misusage of a land, whether that's from fuel or chemical storage or spills, the generation or usage of waste materials, both on and off of property. And what you need to remember is that we have a lot of good environmental regulations today. However, pretty much all of those regulations came into effect during my lifetime, which means that if you go back a number of decades, you start seeing very, very little to no environmental regulations, where really material was spilled on the ground, sometimes intentionally so, to get rid of it. And so you can have areas where quite a bit of contamination from historical uses that still persists over time due to the type of chemicals lost or the magnitude of chemicals spilled into the ground. So for the ARO evaluation process, you go through a stepwise process, starting with the screening, then through phase 1, phase 2, a remedial action plan, doing the estimate, and then at some point going ahead and actually doing the site remediation. Each of those steps takes a little bit more time, and each step becomes more and more complicated as you move through, and somewhat depending on your site. I'm going to talk about each of these, but as I do, I'm going to use an analogy to help simplify the concepts. And my analogy is that of a spilled glass of water and trying to determine the cost in paper towels to dry up that spill. Okay, so as we move through, we start with the desktop screening process. And the desktop screening process is essentially asking the question, is there even a cup that could have water? If the answer is no, then there couldn't be a spill and there's no cost. Okay, and so it's looking at the property use, the history of property, anything you know about the property, and saying, could there be a potential for contamination on this property? If the answer is no, then you can be finished. There's no cup. If the answer is yes, then you move forward. As with most properties, there's a cup on most properties. And so it's not going to be often that you're going to be able to use this to actually screen out a property. You have to have quite a bit of knowledge. You have to know that the site's was a green field before you moved in, and now it's a very basic office, and there's no heating oil tanks. It's on natural gas or electricity, and there's just no potential for contamination. So some properties will come off a list this way, but very, very few. You move forward to the phase one process. Now, the phase one process is where you bring somebody like me in to take a deeper look at the property. Okay, and what we do is we take a look at really what was on this property before. We can search a whole bunch of historical records, aerial photographs going back sometimes to as early as the 1930s, land title searches, other regulatory database and searches to figure out, could there really be contamination? Okay, so in the case of the analogy, this is there a cup? And if there is it sitting on its side? We don't know if it had any water in it ever, but we know that there's a potential for water to have spilled. Okay, and so a phase one can come either to a conclusion of no further investigation, there's no potential contamination. That's always the ideal. It could determine that there is a potential contamination, but the risks are so small and it's so easily understood that we can actually come up with the estimate of cost right at that point. So that might be, for instance, an issue where you've got a rail line on the property, and that is the only concern. And the rail line, the creosote ties, will cause contamination to soil within a couple of feet of those ties. We know that's a common contamination. We also know it doesn't spread any further. And so we can quantify, you've got the rail tie, it goes through the north portion of your site. This much soil might need to be removed when those ties come out. It's quantifiable. We don't actually need to test to see the level of contamination. We can quantify that right off. In most cases where potential exists, we will recommend a phase two, which is to go in and actually figure out how contaminated the site actually is. So the phase two, the phase one, we're looking at risk factors, historical gas stations, underground storage tanks, underground or above ground chemical tanks of various forms. And could there be contamination either from operating or historical or neighboring properties in which the contamination can migrate onto the sites? We've got underground storage tanks are a big issue on a lot of properties. We can see here on the top left corner, this property is serviced by natural gas. But that natural gas got brought in to replace a heating oil, which used to service the building. And you can see the heating oil tank is still in the ground. The picture below that is a heating oil tank actually taken out. That first middle picture, that is, if you look carefully, you can actually see oil sheen on the groundwater there. And this last picture to the right, that is actually a photo taken from inside the tank, and you can see the corrosion pinholes in the tank where the light's actually getting through. And that is because it actually corroded. And that tank still had oil and some water, which obviously was rainwater, but it seeped into the tank in that tank when it came out. So that can cause a fair amount of contamination. And when it's proximal to a building like that, that contamination can extend under a building, which can make it even more expensive or difficult to deal with and remediate, and thus affect the costing to remediate. Chemical storage, the top left picture, the top right picture, you know, those old style chemical storage, those drums up on the right have rusted through and they're empty now. They weren't empty when they got brought to that property, but they're empty now. As I mentioned earlier, a lot of rules have changed. You're not supposed to be doing that top left, top right anymore. It still happens on occasion, but it's not allowed. but it was quite common a number of years back. If you look down at that bottom picture, that's much more common. Current chemical storage, the chemicals are all being stored on a secondary containment. Should any spills occur, they're being assessed, inspected to make sure everything's in good shape. A situation like that wouldn't necessarily result in a need for any further investigation of the phase one, where the top photos absolutely would. Above ground storage tanks and chemical storage. Oh yes, and this is the case of often will result in surface staining. You can see in the left picture that's oil stain on the ground. That is not water. It had been quite dry for a while. That photo was taken. You can see the drum, the bottom right, that dead grass. You can see the dead grass in that top picture. The grass is dying. That's often a sign that there's some kind of chemical impact occurring that is killing or preventing the growth of that grass, especially when there's a lot of other vegetation. Above ground storage tanks tend to be much less of a concern because if they leak, somebody notices them, they often will leak onto another sealed surface to prevent the loss. At the bottom, at the left photo, you can see that it's gone to stormwater drain. Stormwater drains, unfortunately, are designed to leak. And so that oil coming from those tanks is in fact going to get into the soil and groundwater underneath that building. Photo to the right, those are nice double wall tanks. We like those much more. They're much less likely to leak, but you can see that they've got fueling lines on them. And so it's often surprising to me how few people seem to know how to fuel their vehicle without spilling gasoline or diesel onto the ground. A lot of remediations I do at gas stations are a result not of leaking tanks, but of spills during the fueling operations. So there's still some potential of concern based on the fueling as opposed to the tanks themselves. Once we find the potential of where contamination could be, so we've determined that the cup is in fact on its side, we know where the cup is, where it's on its side, so we know where to look to see if the table that the cup's on is wet. And so we design a program to drill holes and actually collect soil and groundwater where it's most likely to be contaminated and where we can go ahead and assess whether or not we actually have contamination. That drilling is done through a drill rig in which we come in and we can drill holes in the ground. We've got these ones, we've got quite a bit larger ones that we can use, and we've got much smaller ones. I have gone into many a dry cleaner to drill. I've actually literally drilled in a china shop once. So we can get a drill rig into just about any location in order to sample the soil and groundwater below it. The costs obviously differential, depends on the accessibility and the type of equipment that I have available to use. Then once we've drilled a hole, we set a well, that's just a PVC pipe with slots in the bottom to let the groundwater enter, and then we can go ahead and pump that groundwater up out of the ground and do some testing to determine whether the groundwater is contaminated. We can also even test underground air to see if there's a risk of vapors getting in through the subslab into a building. The last way that we often will do investigations through test pits, and that's bringing a backhoe out and digging a deeper hole. There are some advantages to this method in that you can see a larger area and get a better sense of what's in the underground, but it's not the more common. There are drawbacks to this method as well. For instance, it produces a lot more waste material when you're digging, and it doesn't allow you to set a groundwater well as easily when you're installing. And we take all that in order to plan for remediation. So the phase two looks at it and says, yes, the cup's on the ground. Yes, the table is in fact wet. And you sometimes need to step out a couple of times to figure out how large a puddle is on your table. Does it go onto the floor? Does it stay on the table? And then you can figure out the remediation plan. And the remediation plan, you start looking at what options do I have for remediation? What kind of time do I have? If I need to clean up something fast versus I've got 10 years to clean it up, gives me different remedial technologies and often different costs associated with those remedial technologies for cleaning a site. Is there a building in the way? Is there asphalt that needs to be removed and then replaced? Is there various infrastructures, natural gas lines, water lines that I need to work around? Okay, so think of that as what kind of paper towels am I using? Is it, you know, the expensive kind or a cheap kind? Do I have maybe a chamois available? What options do I have for cleaning up will affect the costing and the timelines and what I'm doing with that site. For remediating, I got a few common options. One is ex situ remediation, often referred to as dig and dump. This is where you actually dig out the contaminated material and you send it somewhere else to either remediate it or landfill it. This is a common solution. It almost always works. It's a very high likelihood of working. It can work really well if you're going to be doing this along with redevelopment of a property, especially where soil needs to come out of the ground anyway. And so it is a very common and useful remedial technology. Another common remedial technology is chemical or bioremediation technologies, in which you use either chemicals or microbes to actually eat or destroy the bacteria, the chemicals. There's a lot of bacteria that and microbes that will eat gasoline and quite enjoy it. And so you would encourage the growth of those microbes through fertilization or other means in order to promote their growth and therefore break down their chemical levels. This method obviously takes some time. Sometimes we're talking weeks, sometimes we're talking years, sometimes we're talking decades, depending on the kind of chemicals and the concentrations that need to be broken down. But it can be an option, especially where time is your friend as far as remedial technologies go. And the last option often used is risk assessment. That's where you take a look and say, is this actually causing harm? You know, if you've got contamination, it's under an asphalt surface. Maybe that asphalt surface is protecting and therefore no remediation needs to be done. This option usually has the lowest of all the costs associated because you're not actually remediating the site. The idea here, using my analogy, is to look at the table, look at the wet spot in the table and say, you know what? It'll evaporate. It'll dry itself. I don't need to use any paper towels at all. Nobody's going to be using this table for the next day or two anyway. It can just evaporate. And that's the equivalent to this concept. And in many cases, it is a really good environmentally conscious answer and not just cost effective, but a good, smart answer. The end product is we produce this table. And what this table is it looks at the different remedial technologies that we've determined will actually work for the sites. It provides a little bit of information about them, and then it provides a cost. And some of these have annual costs, the remedial risk-based or a long-term natural attenuation where you're using microbes to break it down. There might be an annual cost where you're monitoring to make sure that it's in fact working and progressing. A number of them have capital costs. You know, an excavation is going to have a very large capital cost because you're actually moving this material out, and there's costs, whereas a chemical injection might have a mid-level capital cost for the cost to actually do the injections itself. And there are a number of other costings that we look at, annual, yearly, upfront, post-dated, and look at the various cost range, what our estimates are, and therefore can come up with the actual cost or cost ranges for each technology. And then you can select whether or not you want to go with the cheapest one, but the cheapest one may not work and make sense for that site. So the cheapest one might say, yes, this technology, it's inexpensive, but it's going to take 20 years to implement. And you've got a 3-year plan to redevelop your site. Well, that technology isn't the right technology. You need to select a more expensive one that fits in with the timelines for the sites. Okay, and with that, I will hand the table over.
Wonderful. All right, thanks everybody for attending. My name is Tim McBride and I'm the Director of Landfill and Municipal Services at Pension, commonly referred to as the dump guy. But I want to change that mentality, and I'm hoping to start that a little bit today. There's a misconception that landfills are, just a dump, but they truly are an asset. And we have to change that mentality because, to quote one of my favorite bands from the 80s, Cinderella, you don't know what you got until it's gone. And lots of municipalities are running into this situation now that they're at the end of the life for their landfill site, and they're coming to the realization that replacement and expansion of the landfills is very, very difficult to do. So what we're trying to do is educate people, educate operators of these landfill sites to tailor the operation of the landfill and maximize the site life. And then through that, even work towards a progressive closure so that they don't have to expend all the money at the end of the day to close the landfill sites, and kind of close it as they go through the process of waste deposition. So you can see here, there's two pictures here of landfill sites. One, on the left is very, very common. That's typical to what I see because most people treat landfills like a dump. This other one on the right here is almost like a park, and it's kind of like my prize in my stable of landfills that we work on. So it's very, very clean site. We have very few issues with the regulators when they come to this property. It just makes our lives very, very easy through all the process. So going back to my comment that most people don't realize what they have till it's gone. With the landfill site, if you had a small community and you took the landfill away from them and they had to look at other alternatives like shipping it to another place or a third party to take care of their waste, it can equate to a lot of money. If you just look at the average amount of garbage that a Canadian produces, and then the cost per year for tipping fees for that waste generation rate, for a town of 3,000 people, that's $200,000 in tipping fees alone. That doesn't include your transportation and all the collection and all the other pieces of the puzzle. So that's a significant asset if a municipality were to mismanage it and to lose it. And at the same time, there is a liability associated with the landfill site, and there has to be some planning put in place so that the money is there to properly close the asset when it reaches its end of life. So people often ask me, what does it cost to close a landfill site? And it's similar to what does it cost to build a house? It really depends what you're trying to build, and there's a lot that goes into landfills. In most jurisdictions, landfills are licensed and they have to operate under provincial guidelines, which will dictate the area of the landfill or the maximum volume of the landfill. And then there's operational constraints that also have to be considered, such as slopes, capping requirements, final closure requirements, that sort of thing. So it's really important to figure out what it is we are actually dealing with, and how big the thing can get, and how much at that point in time you can start to quantify what it would cost to close it out. So to do the volumetric calculations of the lifespan of a site, there's a couple different ways it can be done. One, you can estimate it from scales. You can figure out how much you're bringing in tonnage, and then convert that to an in-place volume. The other way to do it, and it's becoming more and more popular, especially now that aerial surveys and drones are becoming way more cost effective, is we fly a lot of aerial drone surveys from one year to the next and see how much did we actually bring into the landfill, and how quickly are we eating up that available lifespan. And then based on the lifespan, we can, and the rate at which we're bringing in the waste material, we're kind of able to forecast when are we going to reach that closure date. Like Margaret said, from that point, we're able to, put a cost to it and back calculate, what the net present value is for the actual closure aspects. So as I mentioned before, what we try and do is we work with, operators of landfill sites to figure out a way to, optimize the landfill operations and get the biggest bang for the buck out of the available space that's there. So this site here is an area fill landfill site. So the waste pile is above grade, and it's got limits on it by the province. And this one that says that they have to have 4:1 side slopes and then a 20:1 crown across the top. So what we're trying to do is have them work to those 4:1 side slopes as part of their operations. So that they don't have to spend a lot of money at the end regrading it to meet the provincial standards and that sort of thing. And in doing so, we're able to tell them here, that you have 20 years left in your landfill site. And once we break that down into smaller, more manageable cells, we're able to tell them how much they can expect in life in each individual cell. And as they close the cells out, they can kind of use this as a forecasting tool. That within 3.5 years they'll be done cell 1 and cell 2, and maybe that would be a good time to put a cap on it. And once that's done, that's progressive closure, and it really allows them to control the costs. The other piece of the puzzle, because landfills, unlike the other disciplines that we're going to talk about today, the landfills stay in place. With TAD's groundwater and soil contamination, the remedial game there is clean the stuff up and get rid of it. Well, there's nowhere to move the landfill, so the landfills will stay in place at the end of their life. So most jurisdictions require us to calculate the contaminating lifespan of that waste deposit and how long will it last and continue to potentially impact the environment. So the default in most jurisdictions is a 25-year post-closure monitoring period. And in some instances, it'll even require that you have a contingency plan and have a very, very robust leachate management plan. So you might have to collect and treat leachate, and again, we have to figure out how long is the landfill going to generate leachate and how long would you potentially have to operate those types of systems. So that's another factor in the post-closure aspect. And as I talked about before, there's definitely advantages to, the phased closure approach. The top left photo here, you can see they have an active landfill face, but at the same time, they have some equipment there and they're applying the, 4:1 slope and the cover system on that, right at that time. And just from a operational standpoint, I mean, you can see what some of the other risks at the bottom here. If you don't, actively cover your garbage, you end up with lots of windblown litter. There's an increased potential for landfill fires, and there's also an increased potential for, nuisance animals and track out of those animals, spreading the garbage all over the property. And then you have to go chase it and collect it and bring it back into your tipping phase. So this is a closure concept. What we tried to do here is develop the landfill site, similar to the other example I showed. We have an active face that we want to work with, minimize that so that we can, control the operation. And then at the same time, work towards final closure contours, put the cap on it, put the vegetative cover on it at the end, and then progress our way around the site in a, in this case, it's a counterclockwise direction. And once we're, completely finished, we'll have a, totally capped landfill site that has a low permeability cover, so precipitation can't infiltrate, and it reduces our leachate generation and reduces our risk and our liability. By doing this progressive closure, again, we were able, you know, as we close each cell, we're allowed to take that liability off the books because that component is already finished. So it's kind of unique as compared to the other disciplines. So for closure concepts, again, we have to know what we're trying to build. Two common cover systems that are, you know, associated with landfill closure is a traditional soil cover. You need, in most jurisdictions, you need 2 feet of low permeability soil, so like a clay or something like that that doesn't let water permeate through it. You need 6 inches of topsoil over top of that, and then you need a vegetative cover to make sure that you don't have erosion and scours. If you live in an area where there's not clay readily available, or you're doing this work in winter time when it's hard to put clay down and compact it, you know, and get the moisture content you need, there are geosynthetic clay liners, which essentially is, you know, 2 layers of felt with a clay in between. So it's a man-made product, and yeah, you can put that down. It's a little more expensive as a material, but it's very, very easy to work with. So you gain some benefits there. So post-closure care, I talked about this briefly. Depending on the contaminating lifespan, that'll dictate your post-closure period. Most jurisdictions, like I said before, require a minimum of 25 years to be carried in the liability estimates. And in that, you have to, you know, account for inspection of the cover, you know, inspection of any infrastructure, roads, gates, anything like that that's associated with the landfill site. You have your water quality monitoring, wells and surface water stations, and then you have to present a report. Again, depending on what your license says for the facility, it could be annually, or sometimes when you reach the closure stage, your consultants are able to negotiate that, you know, things aren't changing that quickly. Yes, we'll monitor it every year, but maybe we only report every 2nd or 3rd year. And then, yeah, you have to have a contingency plan in place in case things are not going according to plan and you are having undesirable impacts to surface or groundwater. And that could be as simple as, you know, acquiring additional land to give you additional natural attenuation area downstream of your landfill site, or it may be that you have to put in an active leachate management system. So this is an example of the closure costs that are associated with the landfill, and that we use to calculate the you know, financial liabilities. So in this case, we have a known landfill footprint. We have some unit rates that, you know, we get from actual contractors in the area that tell us, you know, how much is it going to cost to regrade the waste? How much is it going to cost to put the 2-foot thick clay cap on it with another 6 inches of topsoil? You know, how much is it going to cost for us to go pick up all the windblown litter before we close it out? That sort of thing. We also have a cost associated with development of monitoring wells. You know, in this case, we were going to put in a monitoring well in the leachate area once the cap is on it, so that there's no risk to it being destroyed during the capping process and that sort of thing. So you can see the costs add up pretty quickly on landfill closure scenarios. And then you get into the post-closure scenario. So again, you have to carry costs through your ARO for, you know, the maintenance inspections that have to be done every year to make sure that the cover is performing and is not compromised anywhere, and potentially creating leachate, increased leachate generation rates. And your water quality monitoring program and reporting. Certain jurisdictions, this example is in Ontario, they actually have a formula for how you calculate the contingency number that has to be carried just in case things go wrong. And then all of this is based, or is dependent on where you're at in the landfill lifespan. So if you had a landfill that was completely at capacity, your capacity factor would be 1, and you would have to carry all the costs. This one here, this landfill is at 60%. So our closure costs, you know, we have to carry 60% of that and then factorize it. Because you could stop using this landfill site and then you could just close what you have in place. So there is some flexibility there. You don't have to carry the complete cost for the whole site on every given year. It is based on how much of the landfill site that you have occupied. And I believe that's the end of what I have for you today.
Good afternoon, everyone. Good day. My name is Sean Douglas. I'm the practice leader here at Pynchon. I'm calling in from Richmond, BC this morning. Kaylee, do I have control? Yes, I do. Thank you. And today I'm going to be talking about hazardous materials and how it relates to the asset retirement obligations. So let's start with an overview of hazardous materials. Hazardous materials are strictly regulated under health and safety legislation. Asbestos and other hazardous materials must be handled and disposed of in a very prescriptive manner. And since it includes federal, provincial, and municipal acts and legislation, that makes it a reportable reportable costs under the asset retirement obligation. And this can affect not only demolition of a site, but also ongoing construction, where you have to deal with hazardous materials, asbestos remediation as you demolish or renovate a building or a particular site. And let's talk a little bit about asbestos products. Asbestos was used for many building products because of its unique characteristics. It was heat resistant, it was durable, it didn't conduct electricity, it enhanced fire protection, added insulating materials and strengthening to various types of products. There's well over 3,000 different types of indoor products that were formulated with asbestos. And here's a short list of materials that you might find or will commonly find in buildings, whether it's flooring materials, pipe insulation, surfacing materials, or even roofing products. Asbestos really peaked in the early 70s as far as usage in North America, and then it declined fairly steadily after that through various partial bans and phase outs over the next 20 years or so. And not only is there asbestos to be concerned about, but there's also other hazardous materials we need to consider when we're doing your ARO. And these are also obligated to be dealt with under regulation. So things like lead paint, for example, lead was added to paint to add to durability. It was fairly common through the 40s, through the 70s, and then sort of in the late 70s, it was reduced steadily under Hazardous Product Acts legislation. PCBs is another hazardous material. It's regulated under federal regulation. It does find its way into various electrical components because of its insulating capacity, things like light ballasts, transformer fluids, and it's even actually used as a non-liquid form as well, as a plasticizer. We're finding this more and more. We're finding actually caulkings and paints can contain PCBs. And this was manufactured typically in the USA, PCBs, up until about 1978, when it was halted in production in the US. Canada imported all their PCBs from the US. And then in 1980, Canada closed its borders and didn't import after 1980. Some other miscellaneous hazardous materials could be things like mercury and control switches. This would be the liquid mercury switch, thermostats, or fluorescent light tubes. Now let's talk a little bit about the remediation and costs. So because asbestos tends to be the most significant cost, that's something that we need to look at a bit closer. Asbestos is handled in a very unique way, and there's various levels of handling, whether it's low, moderate, or high risk, or type 1, 2, 3. And those costs is very dependent on the provincial legislation, so the prevailing legislation, the type of materials that you're handling, and the market conditions. A great example of that is out here in BC, asbestos drywall joint compound cannot be landfilled in Vancouver and has to be shipped out of province at a very high cost. So the difference in remediation from province to province does dictate pricing, and that it needs to be very taken into consideration by the experience of the estimator doing the work. A bit more on the remediation costs. So the basics are we're basing the estimates on current pricing. We need to measure all and quantify it. We use unit rates to calculate calculate the remedial costs. And then more importantly, we add contingencies onto the final price to address things like exclusions or things that weren't maybe sampled or gaps in the assessment. So there's really a four-step process for estimating costs when it comes to hazardous materials. The first step is to perform a gap analysis. And this is really going through a desktop exercise, looking at all the historical reports that might be available, reading through them, identifying any gaps that might be there. Maybe there's sampling gaps, maybe the data is too old, maybe the analytical is not as current. Regulation criteria changes over years, and those gaps will dictate the accuracy of the estimate. The second step in the estimating process is to conduct an assessment. And this is where we're doing actual site work. Depending on the quality of the reports, invariably there probably will be some site reconnaissance. And this involves very detailed sampling, quantity takeoff, so measurement on site. Samples are collected and analyzed at a accredited laboratory, and then data management to correlate all the data and draw your conclusions. The third step is to estimate the costs. So now we're taking those quantities that we collected in step 2 and applying unit rates to multiply out through the costs. And as I mentioned earlier, the unit rates need to be very carefully considered on local market conditions, prevailing provincial regulations and federal regulations, and using the experience and judgment of the estimator. And the last step is to tabulate the costs. And this is the reporting phase. Adding contingencies and then clearly stating any limitations that might affect accuracy. And I'm going to go through a couple examples. I got 3 examples of different ways to estimate the costs. The first one, I'm calling it a very simplified modeling process. And this is where the asbestos or the hazardous material inventory is very limited. And we're using sort of a modeling approach based off similar size and use. And so an example could be, let's say building A, there was a remedial budget that was calculated in a fairly detailed budget at $630,000. And this could even be based on a historical project as well. That could have been the final costs. And the building, let's say, is 180,000 square feet. So we've calculated a $3.50 square foot cost per building area is the cost to remediate all the hazardous materials. And let's say we have another building, which is 250,000 square feet. That's a similar size and usage. By applying that rate, we get a price of $875,000. Now there are some issues with this type of example. Number one, we're making assumptions that there's similar products and types are present, that the buildings are similar in construction detail and configurations are the same. And we end up getting a pretty high variability because of that reason. The second example is a bit more of a detailed method. I'm calling this a semi-detailed method. So this example here would be a deliverable that we give on the estimating. Building A, for example, is 58,000 square feet. It was built in 1970. And this is a tabular form of all the different materials that were identified. And you can see actually, though, that on this method, there are some gaps. Some materials that weren't tested. Maybe this was a management grade assessment. It wasn't for detailed construction. So there's several materials that weren't tested. So these items, we can't put cost to them because they weren't tested. We don't know if it's asbestos or not. So we have to account for those in a contingency. So in this example, we've tabulated the costs and we've worked out a contingency of about 20% to account for that. And you can see that this example here is about $1.8 million. The third example, the third example is called the detailed method. And the detailed method is really what's known as I'm going to call it a pre-construction or pre-demolition assessment. And this is building B. It's 106,000 square feet. It was built in 1979, and there was an addition in 1989 or so. In this example here, this is the output from our report. And you can see that there's various materials that were tested positive and negative. But in one case, we did not sample, or the roof was not sampled because could cause leaks during occupancy. So hence, we need to carry a contingency for that. In this case, the contingency, it's fairly low because we have a really good handle on, or really good details on the actual presence or absence of hazardous materials. So in this case, we have a 5% contingency, and we can get a pretty accurate result. So our variability is quite low. So just to summarize kind of the key points when it comes to calculating your ARO with hazardous materials is number one, you need to perform a gap analysis. That's critical. So this is the beginning of the review, looking at all the documents, and having a professional consultant, environmental consultant, look at those documents and make a decision on, what gaps need to be filled. Do we need to do further sampling? Are we going to rely on the reports that are there? And that discussion needs to be clearly had with the auditor and the actual entity. The second one is the expectations. And this is where we need to be very clear on the outcome. You need to have a sort of agreed upon approach with your auditor. Any expectations of missing data needs to be clearly agreed upon so that we can have an agreed upon outcome. The third summary here of key points is really the experience, or really knowing market conditions. The estimator or your environmental consultant needs to clearly understand regional market conditions, which can significantly vary the cost of the ARO calculations. And then finally, the data quality. So if there is any incomplete data or something that's missing or untested, that will certainly dictate the accuracy of the ARO estimate, and it may deliver relatively high variabilities or conservative estimates. And that's it for my presentation.
Thank you, Sean. Thank you, Marcus. Thank you, Tad. Thank you, Tim. Excellent presentations. We are running at the clock a little bit, but I've got one question I'll ask. It's for you, Sean. And I'm going to paraphrase a little bit. Basically, it goes around the decision-making of removing things like floor tiles versus covering them. Is that an option from an ARO perspective? Do you have to account for the ultimate disposal, or is ongoing management a reasonable option in that regard?
Well, there's two parts to that. So for demolition, those materials absolutely have to be removed under legislation prior to building demolition. So number one, they do have to be removed. The second sort of part of that question is if there's ongoing renovations. It really depends on if that material is in the way of the renovation. If it's being affected by the renovation, then yes, you are obligated to remove it under provincial legislation. If it's not being affected, or if it's not being disturbed by the renovation, for example, if you're doing some renovation in the ceiling, changing some lights out, and there's some floor tiles on the floor, you wouldn't be obligated to remove that, and you just manage that in place.
Don, can I chime in on that one as well, please?
Please do, Marcus. Yes, thank you.
Yeah, so from the perspective of adopting the accounting standard, it makes it more complicated with this scenario, but it's essentially you have to estimate the timing for the retirement of the asset. So let's just say you've got a building with asbestos, you expect to renovate it and have to remediate 60% of that asbestos 5 years from now. And then the remaining 40% will be 15 years from now when you expect to demolish the building. Then technically you need to sort of apportion your ARO 60-40 in that regard and discount it back to the current day appropriately. So if you're looking to avoid setting it up because you're going to just cover up floor tiles, that does not get you out of setting it up according to the standard.
Okay, that's a good clarifying answer. Thank you, Marcus. Okay, we are bang on 10 o'clock, which was our schedule. So I'm going to close it there and give thanks to our speakers for great presentations. I had some good compliments in the chat, everybody. So well done. Big thank you. Thank you for Kaylee for organizing this and keeping us moving and keeping us on schedule. And thank you to all our client participants who came to this and keeps making this, this session a success. As you can see, there's a QR code. If you could give feedback on this, you scan that into your camera of your phone. That will help us with future presentations. Do we do more on this subject? Do we go into new areas? We're doing this to share our lessons with you. So your feedback is a critical determinant in us making that journey relevant to all of you. So with that, I will sign off. Wish you all a good Monday. Thanks to all of you and have a good, safe day. Thank you.